So my project for 194-26 was to apply the Efros algorithm in voxelized settings. So the Efros algorithm, as we learned in class, is an algorithm for texture synthesis, and you can create new but like varied textures. So like the algorithm basically works by you look at the neighbor pixels, find the most likely one in your source image, and then you fill in your destination the pixel that matches. So a bit of voxel background. So my algorithm is for voxels, so they're kind of like pictures of the 3D world. And they have a little value in their coordinate. It doesn't have to be a color. So there's a lot of voxel creations done by people out there. This is like just some screenshots from Minecraft, which is probably the most famous of those. So my question is, can we take this voxel data and can we apply Efros Leung to synthesize new voxel data? So basically, we would take these little towns and cities there, and we would make new towns and cities out of them. So like that's the diagram we want to do. We look at the neighbor pictures in 3D instead of 2D, and we apply the algorithm. So challenges, we're going to have recursive dimensionality. 3D just means a lot more pain, more computation. Finding matches is harder, and also voxel values are not exactly equal to colors, and it's slightly different because it's not really a texture anymore. So answers, we must do image quilting because it's 3D, so we're going to be a lot slower. We need to find neighbor pixels efficiently, and we need to define some sort of voxel difference function. So I can show you a video of what I've done. So this is like the source image I started with, and then now this is my algorithm kind of constructing it. I have sped up the video by about 10x. So you can kind of see there's like little pieces and elements from the source image. You can see I used mostly black, mostly straight pieces for rows. You can see that being constructed. Here I used the image quilt of 3x3, and then for the surrounding neighbors, like the window, my window size was 7x7, so it's not too big. So in this one, that was the source image. So the red values, the red box over there, those are kind of like my neighbor pixels. So to reduce speed, to make it slightly faster, instead of searching the image for best neighbor pixels, I just kept a little queue of those, and then like as I finish valuing those, like I construct those into place. And then you can kind of see the result. It looks kind of like the source image, but it's slightly different. So going back to the PowerPoint, so the algorithm breakdown, it's a bit long to explain, so I'll just leave the slide up. The flaws, it's not always clean, it's still slow, it grows exponentially, so there's improvements we can do. But overall, I think it's a pretty cool algorithm. And yeah, that's it. Thank you.